Alright guys, welcome to another video. I thought we'd try something new today. I wanted to talk about a new article that just came out in Science. And so this is the DOI number for that article. It goes, Cyanotriazoles are selective topoisomerase II poisons that rapidly cure trypanosome infections. And so it was by Rao et al. And this is primarily the article I'll be referencing throughout the video. But also there was a follow-up press release to that article by Ruslana Fashajev. And that one I think is a little more plain English, but we'll break it down one by one. And so just before we get started, this research is by researchers at Novartis Institute in California. So basically as big pharma as you can get, but take it as you will. And so what they are is there's something called cyanotriazoles. And so what they do is they bind to topoisomerase II, and what they cure is trypanosomes and Leishmania. And so these are a bunch of flagellated parasites that affect millions of people worldwide. So really the main disease that we care about here in the US is going to be Chagas disease. And we'll get into a little bit about what that is. But essentially I thought this article was really cool. So what these cyanotriazoles, and we'll call them CTs, what they do is they target DNA topoisomerase II. And if you think about what that does, pretend this is DNA. So it gets all tangled up, and then this enzyme basically untangles it. And so it helps with DNA repair. We already have drugs that target DNA topoisomerase II. So two main classes of drugs that already do this are fluoroquinolone antibiotics. So you might have heard of Cipro for treating UTIs, or maybe swimmer's ear. You got those ear drops. So fluoroquinolones are great because they target Pseudomonas. The other use for them is doxorubicin, or technically any of the rubicins. And so where we use those drugs is non-Hodgkin lymphoma. You might have heard of the CHOP regimen, and also with the ABVD regimen for Hodgkin lymphoma. So you'll see doxorubicin, breast cancer, bladder cancer, multiple myeloma. I want to say these are ototoxic and nephrotoxic, but I would double check that with Google. And so cyanotriazoles, they target a group of organisms called kinetoplasts. Now, you may have never heard of that, but three of them that we care about are African sleeping sickness, Chagas disease, and Leishmania. And so just being very general here, this kind of affects Asia. Obviously, African sleeping sickness affects Africa, and then Chagas disease is mostly going to be South America. And so if we think about North America being pretty close to South America, we have thousands of immigrants who potentially may be infected with Chagas disease. So what they did is they found a compound called CT0. And CT0 was already pretty good at targeting these species, but CT3 eventually what they found is what they're going with, and it's even better. So one of the things that I thought was cool is, how did they even know where to look? How did CT0 come about? And so what they did is they used a robot and they tested 2 million compounds against a harmless strain of Trypanosoma. And so if you think about, typically when you have an assay, it's a row, you just have rows of little pipettes, and by hand you pipette a little compound into one, and then a week later you see what it does. Obviously this is very time intensive, and so with robots, they check 2 million of these at once. I thought that was really cool. I'd never heard of these automated cell-based assays. And so eventually they found something that inhibited the parasite, and this was CT0. Now, eventually, CT0 became CT3. And so how did they how did they get from CT0 to CT3? Well, essentially what they did is they looked with a very small microscope to see where CT0 was binding, and then slowly tried different molecules that binded a little bit better to the enzyme. And so the way they visualize these compounds is with something called cryo-electron microscopy. This was really cool. I had never heard of this. It was named Nature Methods Method of the Year in 2015. And so essentially what it is, it's a chamber that you put a little sample into. It freezes it to below 0 temperatures, and then you fire electrons at it really fast. I think the idea is that in the cold, the compound basically doesn't shatter like it would in the heat, and so you can blast electrons at it without breaking it. And so this is the schematic of it, but essentially what you need to know is, it's just a giant fridge that it goes into, and you're just shooting electron beams at it. Eventually you get this very good 3D model. And you've probably seen this before, it's how a protein is represented in 3D space. But it usually costs a ton of money and time to render this. And I think the idea here with this research is that using cryo-EM, they were able to visualize these molecules a lot faster and a lot cheaper. And so cryo-EM is really cool. What you're seeing here is a spike protein from the coronavirus. It was visualized via cryo-EM. So, this is electron microscopy. You're zooming in and then you're using cryo. You're basically getting down to the atom. I want you to think about that. You're able to look at individual atoms. 30, 40 years ago, this would have been so hard to do. And now it's a matter of just giving someone $1,000, which is a lot of money, but in the grand scheme of things, it's not that much. So this is straight from Rao et al.'s article. They were able to show that CT1 was binding to this topoisomerase 2 enzyme, and so this is their molecule here. And so etoposide is another topoisomerase inhibitor. I think it inhibits topoisomerase 1, and so they superimposed it with CT1 to prove, hey, basically this new molecule we're not sure about, it's binding to the same place as something we do know about. They then tested their drug in mice. And so in mice, you can see compared to benznidazole, which is an established treatment for Chagas disease, it worked just as well. And how did they know this will be safe in humans? So it didn't seem to harm the human cells in a tube, and they weren't too bad on mice either. That's all we know for now, but this will go on to further research. And so where we go from here is, CT3 has been identified as an interesting molecule, and it's going to go into phase 1 trials where they just test it in healthy human subjects just to, see if it's dangerous. And so hopefully from there it goes on to phase 2 and 3 trials where we'll test it in patients with Chagas disease. And, unfortunately the thing is we're years out from this being available, if it even gets approved. But it's just interesting to know what the future is. So why do we care? Well, one of the reasons we care is nifurtimox, one of the drugs we currently use to treat Chagas disease. It's hard to tolerate. You start throwing up, you lose weight, you can't sleep, you might get diarrhea, you might get really bad stomach infection. So these are drugs we want to get away from. And if you kind of look here with benznidazole, you can get symptoms similar to cancers. You have no white blood cells, no red blood cells, you're immunosuppressed. You might damage nerves, you might become infertile. So these drugs that we currently use to treat Chagas disease are not very good. They work, but they're terrible. And so if there is an alternative, it'd be very good. So a little bit about Chagas disease, what it is. It causes achalasia, which is when your esophagus can't empty into your stomach as well. And it can also cause heart failure, something called dilated cardiomyopathy. So we get it from the kissing bug, which is found in South America. And, it's estimated that about 15 million people are infected. This has lately become a concern in organ transplants because we don't really test for Chagas disease in America in organs. And so people who receive organs are, becoming infected because they're immunocompromised. So that's about it. I thought this was a really interesting article. Let me see if I can pull up some of the stuff. So this was the article itself. It highlights, a couple of the molecules. So this is CT0, this is CT1, this is CT3. They had some really good graphs detailing the mice that they tested on, some of the organs. It's a lot of very technical stuff. They basically used immunofluorescence a lot. I won't really get into the nitty gritty, but this was some of the stuff that they visualized using electron microscopy. And so I think, in their conclusion, they were basically like, it was safe in preclinical testing and they're excited to advance it forward. So yeah, I thought, that was a really interesting article. Let me know what you thought. And, obviously these videos take a lot of time to make. So if you liked it, please leave a comment. Thanks.